Okay, now a couple properties about exponents. Now, most of these are coming from, if you look at the exponential version of this, they've rewritten it in the log form. So since b to the first is b, anything to the first part is itself. If we were to do our L shape on that one, we get log base b of b is 1. Okay. Now we also have if b of 0 is 1, that's another property that we know out of exponentials, and I rewrite that in its log form. We have log base b of 1 is 0. Now we'll utilize this a little bit when we go into our graph pictures. Now these next two kind of utilize a couple of facts that allow us to do some canceling off of some stuff. So what we traditionally see here is when we see log base b of b to the x, and I'm pulling this onto my board here, okay? So if we take a look, what traditionally happens here is when we have log base b and then it matches with a b and there's an exponent. This log base b and b, they cancel out, which leaves me just the x that was up here. Same thing if I have b with a power of a log base, those two cancel out, leaving me just the x, okay? Now, if we had something like log base 7 of 7 squared, we would have log base 7 of 7 then equals 2. They kind of cancel each other out when that processes, okay? We don't use that a whole lot right now. We do use it a little more often when we're trying to solve things, okay? So we'll see that a little bit later on. Now, if you recall, this was an exponential graph that we had. Now, I haven't discussed it yet, but when we were dealing with kind of intro of logs, what they did here, if you remember, we had b to the y equals x. They have basically switched our x's and y's. If they've switched our x's and y's, that is by definition an inverse. So logs are the inverses of exponentials, okay? So if we utilize that concept, when we've talked about inverses before, what we can see here is this is our 2 to the x. This is straight from our exponential section. I'm going to take this table and we are going to flip-flop the x's and y's, or the x's and the f of x's. So we get this, and now here is our graph shape. Notice it has that same curvature, but it is looking a little sideways. We now, instead of having a horizontal asymptote, we have a vertical asymptote. Okay, so kind of some key changes there. Now, taking a look also at our 1/2 one, and again, playing switches on those x's and y's, or x's and f of x's, we get this, and here is that log 1/2 graph. Again, we see a similar shape. Okay, same kind of curvature shape that we saw there. And again, we're kind of seeing that vertical asymptote. Now, this next slide that I have up actually takes the 2 to the x and the log 2 graph and puts them in the same grid space, and it takes the log 1/2 and the 1/2 to the x and puts them on the same graph so that you can see where the reflection is. Because if you also recall, inverses reflect over a diagonal line, y equals x, okay? So here we've got 2 to the x in blue and our log 2 graph, and that one's pretty straightforward, obvious with that one. Over here, this B graph right here is the one that tapers this way. This is the original exponential, and then you can see where I'm going to use the taper tail first. This taper tail is reflecting up onto this taper tail, and then this arch piece is coming out over here onto this arch piece, okay? Now, couple things about these is you can utilize this as either just switching your x's and y's. You can utilize the idea that they reflect across the line y equals x to obtain these graphs. We're also going to see some stuff where we utilize, again, in the next video where we get into kind of transformations. We're going to do some of those key point type things again,